This lesson is over slope and slope-intercept form. So most of this, actually all of this should be a review from Algebra 1, so hopefully it's just, if you forget how to do it, once I go over the stuff, it kind of sparks your memory. But this is the slope formula we're going to use first. I think it helps to go ahead and label these x1, y1, x2, and y2. Once you get better at this, I a lot of times just label them point 1 and 2, and then you can know which is the x and y. But I think if you label those, especially once you get good at this, you can stop. But at the very beginning, until you can prove to yourself that you're remember how to do this or you're exceptional at this, I would keep doing it this way. So we have y2 minus y1 over x2 minus x1. Oops, I messed that up already. y1 is 8. So 5 minus 8 is negative 3. Negative 4 minus 7 is negative 11. That reduces down to 3 over 11. Now, I highly recommend on this step to just use a calculator. A lot of people get confused with positives and negatives. I do it all the time. So especially if I'm making an answer key, I always use a calculator just to double check stuff. Same thing with this next one. Messed it up already. Sorry, it's late. y2, oh my goodness. 1, x2, y2. Okay. So we have negative 1 minus negative 100 over 0 minus 9. Minus negative is plus, but again, I would just use a calculator. So that ends up being 99 over negative 9, which is equal to negative 11. So again, once you get a little bit better at this, if you just want to label points 1 and 2, you just can tell that your x and y, which ones those are. But I would at least label them with something. When people try to take shortcuts with this, it's when they start making simple mistakes. So y2 minus y1 over x2 minus x1. That's plus, so that ends up being 14 over, that's plus negative 4 plus 4 is 0. So anytime you end up getting 0 in your fraction, whether it's the numerator or denominator, there should be a red flag that goes off. If it's in the denominator, this slope is actually undefined. You can't have a 0 in the denominator. You can never divide by 0. If you can't remember, as long as you have a red flag that goes off when you have 0 in a fraction, put in your calculator. Because if you put in 14 divided by 0, it's going to give you an error message. Or even 14 over 0 as a fraction, it's going to give you an error message. Whereas this one, we have 3 minus 3 over 5 minus 1. That's 0 over 4. This one, there's a 0 in it, but this 0 divided by 4 is just 0. So again, if you just remember that if you have a 0 in your fraction, put it in your calculator, that can help you distinguish between those. Now, you do not need to add this to your answers if I ask this on a test or a quiz, but just in case, just to kind of plant that seed, if it's undefined, that is a vertical line. If it is 0, it's horizontal. So go ahead, do number 5 on your own. I have the answer there. I'll do it here in a second, but pause it, do it on your own, and then hit play to double check your work. Or there's the answer, so if you get that, you can probably skip this. So get negative 5 minus 4 over negative 4 minus negative 2. Negative 5 minus 4 is negative 9. Negative 4 plus 2 is negative 2. That ends up being 9 over 2. Now again, this hopefully is stuff that's a big review from Algebra 1, but I will tell you without fail, there are people that miss this all the time, so even if you think you remember how to do this, make sure you're paying attention. Putting this in slope-intercept form, so that is y is equal to mx plus b. You'll get that on your test. Your m is your slope, your b is your y-intercept, so this is y is equal to 1/2 x plus 5. This one, y is equal to 3x, and then plus negative 4, which is just minus 4. Now, this is a little bit weird. The y-intercept is 0. That's fine. You just get y is equal to negative 3 over 4x. If you want to put plus 0, you can. Technically, you don't need that at all. Put each in slope-intercept form. So essentially, we're solving for y and getting y by itself. This is something that you need to be good at because we do this all the time. Not just in this chapter, we'll do it in the next chapter, we'll do it in the chapter after that. We do a lot of this where we're solving for that y and getting it in slope-intercept form so we can graph it. So for this one, we need to get the x on the other side. Do yourself a favor. I would definitely put my x first. So it's positive 4x, and then the 12 is positive, so it stays positive. Then divide everything by 3. So we get y is equal to 4 over 3x plus 4. Sorry if you can't read that, crammed it in there. This one, we're going to add 12 first. We have 2y plus 3x is equal to 18 plus 12 is 30. Then subtract the 3x, subtract the 3x. Now, here's the deal, remember. Negative 3x plus 30 is going to be your answer for this. If you put 3x minus 30, that's wrong. That's not the case. If you put 30 minus 3x, technically that's right, but you're going to, again, make that 3x, that slope, you're going to want to put first. So the 30 is positive, it stays positive. The minus 3 is negative, so it stays negative. Then after here, divide everything by 2. So we end up getting y is equal to negative 3 over 2x plus 15. So for lack of room, I'm going to erase that. So if you need to see that, you can rewind, but just to make sure I have room for these other ones. Now the next one is in point-slope form, and we'll talk about this a little bit later. But in point-slope form, to put it in slope-intercept form, there's a little trick, and this is why I like point-slope form. Now before I start this, I will tell you, a lot of people say, well, are you going to make me do point-slope form? I'm not going to make you do point-slope form in other problems, but you will have a problem that looks like this, and it says put it in slope-intercept form. So yes and no, I'm not going to make you do it for every problem, but you will have to be familiar with this. So the trick, take your denominator and distribute it to the left. Take your numerator, distribute it to the right. Make sure you remember that a lot of people that miss this, they accidentally do it the other way, and they take their numerator to the left. So 2 times y minus 20 is equal to 3 times x minus 18. Sorry, that 8 looks terrible. Then go ahead and keep solving for y plus 20. 2y is equal to 3x plus 2. And divide everything by 2. You're going to be getting y is equal to 3x over 2 plus 1. Now, another way to do this, if you are good with fractions or if you want to use a fraction button in your calculator, rather than doing that trick, you could literally just distribute 3 over 2 to the x, and then 3 over 2 times the negative 6. You could do that. I don't like to do that because I don't like fractions. I didn't have a fraction button in my calculator when I was in high school, and so I just always did it the other way. I do strongly recommend doing it the way I showed you, but again, if you want to try it with your calculator, since you have calculator capabilities, if you're interested in that, let me know, and I can show you where that is in your calculator. So this one's not in your notes, but just real quick, if I divide everything by 4, end up getting y is equal to 6 over 4 is 3 over 2x. Then 18 divided by 4 ends up being a weird fraction. That ends up being, I would make it a decimal for that, 4.5. Now, I'm going to be honest, I taught this lesson about 2 weeks ago, and so I don't remember exactly why I put this on, but what I imagine is it is possible to get fractions for your y-intercept. It doesn't happen very often. I'm going to try not to do that to you. But on the other hand, if I'm not making you graph this, a fraction or a decimal isn't too bad. Like, that wasn't hard at all. 18 divided by 4 is 4.5. Put it in there. Go to the next problem. If I was making you graph this, I would definitely not give you a y-intercept if that was a decimal or fraction. But again, I'm going to try not to, but it could happen. Don't be intimidated by that because, again, if I'm not having you graph it, it's really not the end of the world. 11 and 12, again, do these on your own. I'll do these real quick. Subtract the 5x. Negative 4y is equal to negative 5x plus 8. Divide by negative 4. Excuse me. Negative 5 over 4 is positive 5 over 4, and 8 divided by negative 4 is negative 2. And that's in standard form. And again, that's another common one that we start with. We'll talk about that in another lesson here soon. Distribute your denominator to the left, the numerator to the right. So you have 4y plus 16 is equal to 5x minus 40. And then get the y by yourself. So now subtract the 16. So we have 4y is equal to 5x minus 56. Then divide everything by 4. You get that answer. Now, I will say point slope form, the reason I do like it a lot, not to go back to this other one, but if you do get a decimal or a fraction for your y-intercept, point slope form is the best way to deal with it. Now again, if you're going to use your calculator for fractions, then maybe not, but I'm definitely going to encourage point slope form. So these next ones are graphing in slope-intercept form. Now here's the deal. Remember earlier I told you guys that I taught this lesson a couple weeks ago. I just graded the test for this like yesterday. And I know a lot of you guys, when you see this, you're going to roll your eyes and you're going to be like, this is super boring. We did this in Algebra 1. It was super easy. But I am promising you that there's people that miss this. Not a whole bunch, but definitely enough that I want to go over this. So make sure you're paying attention. The most common mistake, this is your y-intercept. A lot of people put it for your x-intercept. So your y-intercept is up 1, 2, 3, 4. And then your slope is your rise over run. So that means 3 is positive, so we go up 3 to the right 2. Now, you can remember it as rise over run. That's a really good way to remember it because they both start with R, and that's what everybody's taught. If you can use your notes, I draw this little picture. That's my fraction. Up is plus, down is minus, and then to the right is plus, and to the left is minus. So from here, positive 3 means you go up 1, 2, 3, and then to the right 2, 1, 2. That's your other point. Now, I'm begging you, please make sure you realize, if you go up and to the left, that is quite literally identical. It is the same thing as if you went down and to the right. It's the same exact line. So I went up 3 over to the right. If I went down 1, 2, 3 over 2 to the left, the opposite of both of them, notice how that hits that exact same line. The reason I say that is because there are some times that you end up where your next point is not on your graph, and I have people that throw a huge fit. It's okay, just do your slope on the other side. This one, if you have a negative, again, I put it up with the numerator. I think that's the easiest. So negative 2 is your y-intercept. Negative 4 is down 1, 2, 3, 4, and then to the right 1, 2, 3. Now again, that's the same exact line as if you'd go up 1, 2, 3, 4, and then to the left 1, 2, 3. Everything's the same. Now, one thing real quick while I'm thinking about it, you do not have to use a straight edge to draw these lines. I'm not super nitpicky on that. However, you do need to actually put the points. And if you only do 2 points, that's fine. So if these are the only 2 points you use, that's okay. And this is the reason for that. This happens to me all the time, but if I get sloppy and I just draw this line like this, since I put those 2 points, that's fine. I can tell what you meant. But if you don't have those 2 points, all of a sudden it looks a lot like you guessed and just got close. So you either need to be very, very exact, or just put your 2 dots there, 2 or 3. And this next one, the y-intercept is 1. Remember, if it's not a fraction, you can always make it a fraction by putting it over 1. So up 2 over 1. And again, that's the same thing as down 2 over 1 to the left. It's the same reason why positive 2 over 1 is the same thing as negative 2 over negative 1. And early this negative slope, negative 4 over 3 is the same thing as positive 4 over negative 3. It's all the same stuff. Now, there are some special cases we'll talk about. So x is equal to 4 is a vertical line. Y is equal to something is a horizontal line. So notice what these have in common. The 16 is just x is equal to a number. There's no y at all. Same thing with number 17, except for the opposite. It's y is equal to, there's no x at all. So x is equal to 4, so that means you go 1, 2, 3, 4. The way I remember this is because it has, those are your intercepts. So x is equal to 4 means your x-intercept is at 4, so that's a vertical, try to do a little bit better. A vertical line. And the slope of that one we talked about earlier is undefined. Vertical lines are all undefined. The other one is your y-intercept is negative 3, so that looks like this. and the slope is 0. And again, whatever you need to do to memorize that, that's fine. So I remember somebody told me one time that if you tried to walk on this slope, that'd be fine, but if you tried to walk on this one, you would fall and you would be undefined. That's how you remember that's fine. Then the last one, y is equal to 1 half x. Now I'm going to change this, and I should change this in my notes later, to just y is equal to x. That's what gets a lot of people. Y is equal to x. That's literally slope-intercept form. The y-intercept is 0, so we start here at 0. And the slope is 1, so it's 1 over 1, so you just go up 1 over 1, up 1 over 1. And if you think about it, not to go into too much detail, but that makes sense because these are our x values, 1, 2, 3, 4. These are our y values, 1, 2, 3, 4. So if your x and y are equal to each other, it's going to go through 1, 1, 2, 2, 3, 3, 4, 4, so on and so forth. So we talked about this a little bit. Oh, this is another. So positive and negative slope, really good way to check your work. As you go from left to right, just like you're reading, if it goes up, it's plus, or it's positive. If you go down, it's negative. Then we just talked about 0 and undefined slopes, horizontal, vertical lines, and again, your slopes, your fractions are going to look like this. 0 over some number is a 0 slope. Any number over 0 is an undefined slope. So write the equation of a line in slope-intercept form. So occasionally they give you these 2 points really nicely. Sometimes they don't. Don't make this harder than it is. Find your y-intercept, positive 1. Find your slope, down 1, 2, 3 over 1. Then put that in your equation. Y is equal to negative 3x plus 1. Now I would highly recommend when you find your slope, always start with the left-hand point. If you do that, then your numerator is going to be negative, but your denominator never will be, because if you start with the left-hand point, the next step is going to the right. But, again, you don't have to. Anything will work out. So same thing with this one. Your y-intercept is negative 3. And then find a nice even grid point. If you can't tell, choose another one. So we go up 1, 2, 3, 4, 5. To the right, 1, 2. So y is equal to 5 over 2x minus 3. This one, the y-intercept is 0. I went up 1 over 2. So y is equal to 1 half x. If you want to put plus 0, you can, but you don't necessarily need that. And this one is a vertical line. Vertical lines are always x is equal to, and then whatever that x-intercept is. So again, go ahead and do these on your own. This one, we have y-intercept of 4. Down 1, 2 over 1, 2, 3. This one, xe4, 1, 2, 3, 4, and that is a vertical line. Mine's not the best, but that's okay. And this one, your y-intercept is negative 5, and you go, looks like up 1 over 1. So y is equal to 1x, or just x minus 5. And again, if you put a 1 there, that's fine. This one is horizontal, so it's y is equal to, and the y-intercept is positive 3. Now, I know this makes the lesson a little bit longer, but while we're going over graphing, we might as well go over inequalities. And again, especially because this is all review really anyways from Algebra 1, even if you don't remember it, you have it in Algebra 1, so hopefully you're remembering it by now. So you do the same exact thing where you're graphing these. The only difference is now we're going to end up with solid or dotted, and then we're going to shade. So, step 1, put it in slope-intercept form. Make sure your y is on the left. That's going to help. These first two are already like that. Then graph the line. So we have up 3, then up 1 over 2, up 1 over 2. I usually do 2 extra points. I usually end up with 3 total. And then make sure you remember if it's solid or dotted. Remember, if it doesn't have the equal to line in it, it's dotted. If it does have the equal to sign, like 28, then it's solid. Now, the reason I always put it in slope-intercept form, because there's other ways to do this, but the reason I do that is because it's really easy to graph after this. If y is less than, it's always below. If y is greater than, it's above. So you just shade below that one. This one, 1, 2, 3, 4. Y-intercept is negative 4. Then I go up 3 over 1, up 3 over 1. It is a solid line, just like I said. It's got the equal to with it. And this one is y is greater than, so we shade above. Now, if you have a line that's almost straight vertical, again, you just have to decide in above or below. Usually you're right. But if all else fails, you could also add this to your notes. If y, whoops, if y is less than, it's below or to the left. If y is greater than, it's above or to the right. So if you do end up with one that's pretty almost vertical, y is greater than is also on the, sorry, I feel like I just did that wrong. I guess basically I know with a straight vertical line, let's do it that way. So maybe I said it wrong. So if it's a vertical line, that means it's x. If you shade to the right, x is greater than. So you shade to the right. If x is less than, you'd shade to the left. So that maybe doesn't necessarily work out with your y value. Maybe it's the opposite. I apologize about that. I was doing it based on if you have an actual vertical line. So scratch what I said unless it is actually a vertical line. Other than that, even if it's close, you can pick an above or below. If you have it in standard form, if you want to find the x and y intercepts, you can. Obviously, this one's not great because your x-intercept is a fraction. But again, it's going to make it a lot easier to graph if you go ahead and put it in slope-intercept form. Now remember, through all this work, a lot of people forget that when you divide by negative, you still have to flip your sign. Oops, should be an x there. So negative 2, I go up 1, 2, 3 over 1, 2, 3, 4. It is a dotted line. And now y is less than, so you shade below. This one, you won't have a lot of these, but again, putting it in slope-intercept form, we have 3y minus 3 less than or equal to 2x plus 12. Again, several ways to do this one, but this is the way I'm going to do it. If you want to know a different way or if you have questions about a different way, let me know. I can definitely answer those. But I'm going to stick with this way as far as the whole class instruction. 3y is less than or equal to 2x plus 15. There's actually a way to graph point slope form, and it's not really even that difficult, but it's a little bit confusing, and I've seen people that when I teach that, then they start missing other ones because it's just an extra thing to remember. So 1, 2, 3, 4, 5, then up 2 over 1, 2, 3. This one's a solid line. And again, I always check my slope-intercept form. Y is less than, so we shade below. So do these on your own. 1, 2, 3. You go down 1, 2, 3, 4, 1, 2, 3, 4, 5. It's dotted, and you shade above. If you ever accidentally do a solid, don't erase it. Just put the word dotted beside it. That happens to me a lot, especially with the stylus. And this one, put it in slope-intercept form. I know I already have that for you, but I want to show you my work since I have you. 5 by 6. I get y is equal to, or sorry, y is less than or equal to, see I messed it up on that one too. Y is less than or equal to negative 2 over 3x minus 2. So negative 2. I don't know what happened here with my stylus, but that's okay. Down 2 over 1, 2, 3. Solid. And y is less than, so you shade below. So if you have any questions, make sure you let me know. Again, I'm hoping this is all Algebra 1 review. However, if you struggled with this, don't say, oh man, this is Algebra 1 review. I'm definitely going to be screwed on this. I'm dumb and I don't know stuff, or whatever you get down on yourself. Don't think that, because it is Algebra 1 review, and I hope that you guys all remember, and I hope it's easy for you. But I went over it for a reason. I know a lot of people don't remember, or a lot of people need that little spark to help their memory. But if I thought that everyone should know this, I would not waste my time doing it in class. So don't worry, that's the whole reason I went over this. That said, if you still don't know how to do this, or if you still don't remember after this lesson, definitely make sure you're asking, because we want to make sure we get this stuff down pat. Thank you.